Capacitors, question 2. A 470 microfarad capacitor stores 250 millijoules of energy. Calculate the potential difference across the terminals. Well, for this we can use this equation along with the capacitor equation. Substituting this term for Q gives us the energy as half CV squared. Rearranging for V, we get V is equal to the square root of 2 times the energy over the capacitance. Putting in the values gives a potential difference of 32.6 volts. The capacitor is connected across a 100 kilo ohm resistor. What is the initial current? Well, initially we'll have the full 32.6 volts across the 100 kilo ohm resistor. So we can use current is equal to potential difference over resistance. Putting in the values gives an initial current of 32.6 times 10 to the minus 4 amps. What will be the potential difference across the terminals after 30 seconds? Well, here we can use V is equal to V naught e to the minus t over CR. This equation is given for Q on the data sheet, and we can also use it for I or for V. Now, the V naught was 32.6 volts, the initial voltage, the time 30 seconds, the capacitance 470 microfarads, and the resistance 100 kilo ohms. This gives a potential difference after 30 seconds of 17.2 volts. After how long will the potential difference have dropped to 10 volts? Well, again we can use this equation, and we know that the V over V naught is 10 volts over the initial potential difference of 32.6 volts, which is 0.31. So we can write that 0.31 is equal to e to the minus t over CR. Taking natural logs of both sides, we get ln 0.31 is equal to minus t over CR. Rearranging for t, we get t is equal to minus the capacitance, 470 microfarads, times the resistance, 100 kilo ohms, times ln 0.31. And this comes out at 55 seconds.